In this video, I'm going to quickly demonstrate a new configuration interface for our EFM exporter for the Emerson FB automation platform. This user interface supersedes the previous method to configure the EFM exporter, which was by manually editing JSON formatted configuration files. So let's get started. Right here you'll see the user interface. The first thing we're going to do is we're going to create a new project. So I'm going to give my project a name. I'll save that project and you'll see that the project folder is created. The first thing I'm going to do after that is I'm going to add a device. If you're familiar with our EFM exporter, what we do is we connect to an OPC server, a DMP3 OPC server. In this case, we're going to connect to our own top server, and I need to create a device that's going to connect to that OPC server. So it gives our device just a name. If I double click on that, you walk through the configuration of the device. I can give this device a name. The device ID code is going to be just something that's relative to our device. This is the folder that all of our data files are going to be stored in. I'm going to give this the same name, and you can enter notes. We've got a FB3000 RTU in the Software Toolbox Lab. So I'll just put some notes here. And then we'll walk through the configuration. This is just a simple, the base folder path. In most cases, you can just leave this as the default. However, you can change the folder if you'd like to store the files that are retrieved from the device into a different folder. That is modifiable or editable. The connection settings is really where everything happens. So we've got our OPC endpoint, which in this particular case I'm communicating to an OPC server that's local to my machine, so I'm just using the default of localhost. This is the port, but if you did have this an OPC server that was remote, you could specify the host machine and the port that you're going to communicate to that OPC server. OPC namespace, we're going to communicate to top server. This is where the files will be stored. You'll see that this is where the base file folder came into play, and it's going to create a folder called upload temp. The files as they're retrieved from the device will get stored into this temporary folder, and then this is where this is where the connection occurs. And I happen to know that my channel is DMP3 or DMP Lab, and FB3000 Lab is my device, and then we're at file control. So if I bring up my top server configuration, and you will see that this matches up. This is my channel, this is my device, and file control. These tags are the ones that actually we're going to communicate through to retrieve data from the device. So after I've got my connection settings, these data file acquisition settings are ways in which you can kind of control, depending on your telemetry network, depending on your communications infrastructure, you might need to tweak these because this handles timeouts and retries and things like that are relative to communication. It also allows you to configure, how many history records you want to get at one time, how many event records, etc. So all of that is modifiable and tweakable. I'm just going to leave it at the default. There's no need. I know that they work for my scenario. Logging parameters. This is basically we log to the Windows event log, and you can specify the verbosity of the types of information you want to see in your log. I'm just going to leave it at the default of information at this point. And then the schedule specification. So in most cases, you're going to collect EFM data, say once a day, and I'll leave it as daily, every day. I'm going to get rid of this. I don't need to repeat every hour. If you needed to do it more than once a day and you wanted to get EFM data like every hour, you would leave that number specified for the repetition interval per hour. And then the start time. Let's say I'm going to get daily files at right after midnight, right after the RTU closes off the day. I'm gonna get those data files from the RTU. That's pretty much it as far as specifying or creating a device. So once I save that off, then the next thing I do is I just need to configure my exporter. So this is what we call our data reader. This device basically is going to execute our data reader, and then once we get the data from the device, then we will export that data into the format that you need it in. And at this point in time, we support CFX export, and we also support exporting the data to a database. So let's take a look at the CFX exporter. So I'll add a CFX exporter. I'll open that up, and there's some general things I can name it whatever I want to name it. That's really just for what gets displayed here in the tree view. There's some information relative to where the CFX files will get stored. There's a base folder path again that we specified earlier that was specified on the device. And then it's going to create a folder called CFX, and then you see that it creates a folder for the device name we've given. And then the exporter name can be whatever you want. This unique ID is not really important. It's kind of used internally. Then we specify the schedule for that. So keep in mind that we retrieve the data from the device, and then subsequent to that is when we want to export that data to our export format. So in this particular case, if I'm getting the data right after 5 minutes after midnight, I'll want to maybe give that a little bit of time, and then I'll maybe 10 minutes after I want to take that data and I want to export it to a CFX file. So I'll specify this one at 12:10, and same thing with log. I can specify my logging parameters, and then there's some extra stuff here that in most cases you won't need to use. However, it gives you the flexibility to manually map data from history, from the device history into the CFX file if the need is there. Our solution uses enumerators that Emerson provides in their device and their history header files to know what the data is and how it needs to be mapped into a CFX file. But let's say I want to add data into my history records that is not necessarily EFM data, but CFX files support user-defined data and other types of data that may not be directly relatable to data I'm storing in my history records. You can map that manually through this functionality. So if I bring up this, for example, and I wanted to add a meter in here, let's say I've got a DP meter and it's my first meter, and I had some data that I'm storing in my history records in history point number 6, and I wanted to put that in my user-defined field in my CFX file. I could just come here and specify 6 here, and that's all I really need to do. And if I wanted to replicate that, and because I had multiple meters, I could do that quickly through the replicate and change it to meter 2, and you'll see down here that user-defined is point number 6 in that. Now, you got to understand your history configuration, obviously, to be able to work with this. This is more of an advanced functionality, and if you understand the way your history is structured, what point number and what data is in each point, then this is something that you could walk through pretty easily. And once I save that off, I could do that for meter fields, and I could also do that for my liquid fields as well. So if I add it here, you'll see that these fields are different. So all of these fields are relative to what you would find in a CFX file, whether it's gas or whether it's liquid. And then there's also the same functionality if I'm doing transactional history. There's also the same functionality for batch recording, for example. And this would give me all of the fields for a batch report within a CFX file. So again, this is advanced functionality. It's not necessarily required because we do pull from the enumerators. However, if you need to manually map data, the functionality is there for you to do so. So I'm going to just OK this. Now I've got a CFX exporter. Now in most cases, I'm not going to have export to CFX and export to DB. I might have a different device that I want to export data to a database, but I'm just going to quickly show you the database exporter as well. Like I said, in most cases you're not going to do both on the same device, but let's open this up and I'll just show you how simplistic this is. This is, again, give it a name, the database connection. This is really all you need to specify. So this is We support ODBC drivers, so this is where you specify your connection string to connect to your database. Now, there's some things we have to do, at least currently, to set up the database initially. So I would set up a database called FD3K data collector, and then this creates the connection through the SQL Server ODBC driver to get the data into that database. And then I specify the schedule, like I did with the CFX exporter, and that's pretty much it. So, and then it will take all that data that it retrieves from the device, and it will stuff it into the database of choice that I've created. Currently, we have databases created for SQL Server, various versions of SQL Server, but if you have another database that you need to get into, let us know, and we'd be happy to create the infrastructure for whatever database you're using, Oracle, etc. So that's really about it. And once I get my project defined, I will save this project. Or what I'm going to do first is I'm going to apply, and it's going to ask me if I need to save the project. So I'm going to save the project, and then it applies the changes. And what that application of changes does, it actually creates the schedules, and we use the task scheduler, the Windows task scheduler. So if I look at my software toolbox folder and the FB3K DMP export, you'll see that it created schedules, task schedules to be executed for my data reader, which is going to read the data from the device at 12:05 a.m. every day. You'll notice that it gives you, this is the Windows Task Scheduler, so to let you know when it ran last, what its next runtime is, when it's going to trigger, etc. So then here's my DB exporter that I didn't change the trigger time, but then here's my CFX exporter, which we just saw that we specified 12:10 a.m. So this is what's going to run those tasks, and they're going to run in the background and execute, and this is going to retrieve the data, and then this is going to export it to a CFX file for me when it retrieves the data from the device. So as you can see, fairly simple walkthrough to configure our EFM exporter, and it does use an OPC server, so you saw the way I configured the OPC server to communicate via DMP3 to the device and the connection between the two, and that's how you configure everything. So that's all I really had to show at this point. If you have any questions, please reach out to us, and we'll be happy to talk to you about either this solution or any of your general automation initiatives.